Hi everyone, welcome back to Kimban. Let's start with the unit 1 solutions. In this video we will discuss about the types of solutions. Let's start with the fundamental terminology. Solutions. What is meant by a solution? In fact, when we talk about a solution, we should understand that almost all the processes in our body are happening in the form of solution only. We can say liquid solution. So solutions can be like liquid solutions, gaseous solutions, as well as solid solutions. So basically, what is in base solution? When somebody asks, we can say like it's nothing but a mixture of two or more components, and the thing is that it should be a homogeneous mixture. This is the keyword. So a homogeneous mixture of two or more components is called as a solution. So whenever we say solution, it has two components. One is solvent and other one is solute. Okay, so let's imagine you are trying to make a salt solution at your home. Let's imagine you are taking a table salt and you are adding some water in it. In this case, you have added only one solute. Am I right? Or we can say there are only two components. Okay, so two components here is one is solvent and the other one is solute. In this case, your salt, table salt, right? In case if I add little bit of sugar also, it becomes tricomponent. Okay, tricomponent means you have the first component of solvent, second component of salt, third component of sugar. Like that, you can add many other soluble items to a solvent to form solutions. In that sense, there are several types of solutions like binary solutions, ternary solutions. Your class 12 CBSE portion considers only the binary solutions, which has only two components, which means one is solute and the other one is solvent, right? So when we talk about two components, let's imagine what are the two components. Basically, you should have at least one solvent and one solute. Okay, so there are three types of solutions given in your book. The first type is gaseous type, gaseous solution. In the case of gaseous solution, there could be three possibilities by changing solvent. Okay, so whenever we say gaseous solution, it means that the solvent is a gas. There will be many occasions where you get confused to identify which is a solvent and which is a solute. Okay, so the easy way to identify the solvent is that whatever the solution you speak of, the major portion is called as solvent. Major portion of a solution is called as solvent, and whatever the minor portion of a solution is called as solute. Okay, again the same example. We say you have taken water and you have added some salt. In this case, water is the largest portion, major portion, and the sodium chloride, the salt is the minor portion. That is why i- the sodium chloride becomes the solute and water becomes the solvent, right? So this is a basic idea you should keep in your mind, because there will be examples given to you during the board exams or in the NEET exams also. uh, they will give the example and you have to find the type of solution. For example, uh, oxygen dissolved in water, camphor in nitrogen, or glucose in water. Whenever they say in something, that means that latter part is the solvent. For example, this system whatever we have discussed here, this one is supposed to be called as sodium chloride in water. Okay, so like that. So remember that the major portion is called as solvent and the minor portion is the solute. So whenever we say gaseous solutions, that means the solvent here is the gas. Okay, so solute could be different. If I take a gaseous solute and gaseous solvent, what will happen? What could be the best example? That means gas is gas is dissolved in gas, right? So the best example is our atmospheric gas. Okay, our atmosphere consists of lot of gases. Okay, our atmosphere consists of lot of gases, where it has many of the mixture. It's not only consisting of oxygen, but it also has nitrogen, sulfur dioxide, carbon monoxide, carbon dioxide. So our atmosphere is the best example for gaseous solution. But in our case, in our book, we consider the binary solutions. That means that one solute and one solvent. So in our book there is example oxygen in nitrogen gas. Okay, we can write this one. And the second type is solute will be liquid in gas. Liquid in gas, you have to say like liquid in gas. The question will be coming like that, liquid in gas. The best example is chloroform mixed with nitrogen gas. Chloroform in nitrogen gas. Okay, in this case nitrogen is a kind of gas which has very cool temperature. So when you mix small quantities of chloroform into the nitrogen, it will mix with it, so that it is called as a solution. Homogeneous mixture will be there, so it is called as solution. And there is a third type, solid in gas. Okay, solid in gas. The best example is camphor in nitrogen gas. Why camphor in nitrogen gas? It could be your oxygen also, it is okay. You can even write camphor in O2 gas also, that is fine, because when you fire the camphor, ignite the camphor, it burns uh, because of the presence of the oxygen. So you can say camphor in oxygen, that is also okay. All right, so these are the three examples for gaseous solutions. Let's look at the liquid solutions. Liquid solutions, again similar to gaseous solutions, we will have a solute section and a solvent section. By default, solvent will be liquid. We will start with the gas. Gas in liquid. What could be the best example? Oxygen dissolved in water. In fact, this is called as dissolved oxygen, right? This is the oxygen used by the fishes or even the frog when it lives under the water. Okay, because like we breathe as a territorial animal on the land, fishes and the other aquatic organisms, they breathe under the water using the oxygen dissolved in the water. Okay, this is one of the best example. And the other one is liquid in liquid. Best example is alcohol. Ethanol in water. We can simply say alcohol. Okay, because the 100% alcohol is used only in the standard laboratories. Whatever the commercially available alcohol, they are all nothing but the mixture of ethanol. In the organic chemistry unit alcohol section, you will be studying about the methanol and ethanol, where you will know about the liquors. Okay, so ethanol in water is a best example for liquid in liquid. Even sometimes I used to say funnily that whatever the milk we buy from our milkman is also a best example for liquid in liquid solution, because our milkman mixes water with the milk, and eventually it becomes a homogeneous mixture, and you are unable to distinguish between the water and the milk. Okay, so that could also be a example for that. And the third example, solid dissolved in liquid. This is the commonly known solution. Whatever solution we talk, most cases we can understand. Whenever somebody says yes about a solution, you will easily imagine that we take some solid and we dissolve in liquid. Okay, so this is a commonly known solution. uh, and the best example could be salt in water or glucose in water. You can write whatever you want as long as the solute is a solid. Glucose in water or salt in water. Okay, so the imagine of different possible examples also, because some of the times even in board exams or in NEET exams also, they used to ask some tricky questions. Okay, so whatever the things you study here, imagine of a different possibility of mixture of solutions, right? So liquid solutions. The next one is solid solutions. Similar to the previous ones, we will have the solute section and the solvent section. Solute will be, we will start with gas dissolved in solid. You may imagine like, sir, how come a gas can be dissolved in a solid? In fact, uh, this happens in catalysis. Okay, catalysis field, where they pass the hydrogen gas onto the palladium. Palladium will be a fine powder, and they will pass the hydrogen gas. They become a homogeneous mixture. Okay, in catalysis field, this is working well. This is the best example I can say. Gas in liquid. Okay, sorry, gas in solid. And some of the foams also, um, even sometimes I used to say the semi-solid items like the ice creams, they are also kind of gas in solid, but they are all semi-solids. Let's look at the next type, liquid in solid. Liquid in solid, the best example is amalgam. Amalgam of mercury with sodium. So sodium is a solid, and when you add mercury, mercury is a liquid metal, right? So when you add liquid metal with a solid, they form amalgamation. Some of you might have experienced, or some of you will experience when you go to the colleges. uh, Whenever you see mercury at the physics laboratory or chemistry laboratory, students used to play in their hands. Some of you might have had golden ring in your fingers. In those cases, the mercury will be surrounding the gold ring. Instantly, your gold ring will look like a silver ring. Okay, that kind of things happen because of the homogeneous high surface coverage of the amalgam. Of course, it is hard to remove. Also, you have to heat it to certain temperature to vaporize the mercury. And the difficult part is that when you try to remove the mercury on the gold ring, the copper already mixed with the gold ring also will come out. So eventually the gold ring color will be changing. So just an example, liquid in solid. Okay, and then solid in solid. Best example is your gold ornaments. Gold. Okay, because in gold you add gold plus copper, right? We used to say 916 gold, right? Which means that 91.6% of section is gold and rest of the 8.4 percentage is copper. Okay, this is a homogeneous alloy. We add copper to the gold to make it flexible, because the pure gold is not much flexible to make any ornament or structures. So adding of small quantities of copper gives it more flexibility. So this can called as a solid in solid solutions. Thank you.